All right, welcome everyone to my 12.5 pre-class video. I admittedly got a little bit distracted. You can see it's quite late out and everything, what with the quiz and fair number of emails and Piazza posts and whatnot, but I think it's finally settling down. And so I remembered, oh, there's class tomorrow. I need to have a pre-class video and everything. And so I thought this may be an interesting place to start. This was made a few years back about difficulty in Math 234. And as you can see, kind of things get more difficult, admittedly. And this is kind of an average rate. This is students were asked to look back after they've seen all of Math 234, think about it, and kind of rate kind of how difficult things were. And they're, of course, made up scales, right? It's basically on a scale from 1 to 10 of difficulty units and things like that. And then you average them all together. And the big thing here is that you can see that 12.5 does get a significant bump over 12.4. And we do get 2 days for it and everything. And I guess there's a lot of, I could say about this. We are rearranging things to try to make this a little bit more leveled out. But still, there's a lot of difficult stuff that comes, near the end, and kind of because math builds on itself, kind of that's to some extent inevitable. But we are trying to move some things around. So, for instance, you get 16.6 considerably earlier, at least a part of it. You get 59 and 58, at least parts of it considerably earlier. But anyway, 12.5 will be arguably more difficult, and at least for other Math 234 students, this is what they've rated it. And I kind of, I agree with this, that there are a lot of variety of problems that come up in 12.5. You'll really feel it when you do the web work homework. And so it's important that you spend a lot of time on this section, that you get things straight. And that's going to really help you, of course, on the future quiz and exam and all that sort of stuff. A few other kind of just small administrative things. There's really nothing here right now, but so the quizzes are going to be graded. The graders and myself and the other instructors are meeting tomorrow to kind of go over how we're going to grade these things. We got to make some decisions, things like this. Our goal right now is to have things graded typically by Sunday night, at least for the quizzes. For the exams, it'll probably take a little bit longer and whatnot. But for the quizzes, we're hoping by Sunday night, we'll have all these things graded. So that's when you should expect to see your scores, and we'll go through the, we'll publish with the partial credit and all that sort of stuff. So this will take some time for us to look at everything. Okay, and with that, let me go ahead and I'd like to jump into 12.5 a little bit. I thought I'd do a very traditional pre-class video here. So I just have the textbook and a PDF version of the textbook, and I have it gone to 12.5 here. And I thought I would just kind of hit a few highlights and see some things that, you should be expecting to encounter in your 12.5 class. Let me go ahead and move myself up there. So the first thing, when you're talking about lines in space, you'll see that they actually have an equation that's very similar to lines in a plane. Normally we have something like y equals mx plus b. And so it's kind of maybe rearranged a little bit here, but we can see that t is our variable. It's good to think about these things as time, for instance. So think of time as our variable. That's kind of like the x. Normally there's mx, right? So there's something that tells you about the direction, right? Usually slope is telling you about the direction. And that's what's going on here. This vector v is the direction vector. It's telling you in which direction the line is heading. And so when you look at this picture down here, which is very nice, you can see that here's the direction vector v, and notice that the line is running parallel to this direction vector. So this is the direction that the line is going in. And then the other thing that you need is a point that the line is going through. So normally when you do like the whole mx plus b sort of deal, you specify the y-intercept, right, where it crosses the y-axis. Here, actually, this can just be any old point, which we're going to denote with r0. And this literally means what is your position at time 0. So that's with the sub-0 and all that sort of stuff. So whatever your position is at time 0, you can see it over here. And then maybe at time 1, you've gone this far. At time 2, you keep going. If you were to run time backwards, you'd run in the other direction. And so this right here is the vector equation. And just as an FYI, sometimes instead of variable, we use the phrase parameter. This will come up again and again in this class. So it's good to just kind of get that under your belt now. So the parameter t, just think variable, the variable t. So you're plugging in different times, essentially. The other way that you can sometimes write these things, lines, is a set of parametric equations. So remember, these all have coordinates, right? So these are the different points, the x, y, z coordinates at any given time. And so if you say that your initial point r naught is given by, sorry, I've been working out in the garage a bit and I inhaled some sawdust and I feel it in my throat. But x naught, y naught, z naught, if that's kind of your initial point, and your direction vector is a, b, c, then notice kind of correspondingly, your x parametric equation is going to be, well, the initial x position plus at. So you just look at the x coordinate of the direction vector. And likewise for y, and likewise for z. So these are kind of maybe what you would expect. So this is another good way that you can write a vector equation, an equation for a line is as a set of parametric equations. All right, so that's all about lines. Of course, you can do some things with that. You can kind of generate equations of lines with very specific points and specific direction vectors, and so you get a little bit of that here. There's also another way that you can specify a line, and that's with symmetric equations. We don't really bring these up at all. These don't come up in the WebWork homework, and traditionally they haven't been on quizzes and exams. So more or less you can kind of forget about this, but this is just if you were to solve each one of these things for t. So it's not so surprising here. All right, now let's kind of get into, well, I guess the book does talk about a line segment, and this will be useful here and there, especially maybe as we want lengths of curves and things like this. A line, of course, goes on forever, and so the length of it's just going to be infinitely long. But if you have a specific line segment, a starting point and a stopping point, then that has finite length, right? And so you could calculate out that distance or the length of that line segment. And so this is how you can generate a line segment, so something that doesn't go on forever. Essentially what you're doing is you can see here that you're restricting your t values. Your t only ranges from 0 to 1. Up here when we were talking about lines, I kind of skimmed over it, but t is in all real numbers. So t goes on forever in both directions, towards positive infinity, towards negative infinity. And so the fact that time goes on forever here gives you this entire line that goes on forever in kind of both directions. So that's how you could do a line segment. Now getting into planes. Planes are a little bit different. The special vector for a plane is its normal vector. So for a line, it's the direction vector, v, and for planes, the special thing is its normal vector. And so a plane is a set of points that goes through a specific point here and is perpendicular to or normal to a specified vector. And so if you take the collection of all the points that, if we were to draw lines to them, that these kind of vectors are perpendicular to one another, the thing that you get is a plane. And so for a plane, you really need two things. You need a normal vector and you need a point that it goes through. And again, this is very similar to lines. For lines, you need a direction vector and a point that it goes through. So, right, you can kind of see there's some similarity here. But instead of having, coordinates, x coordinate, y coordinate, z coordinate, for a plane, right, if you were to go ahead and solve this out and actually take this dot product, you're going to get kind of a classic equation that we maybe know and love here. And of course, you've seen this maybe from the coordinate planes, the xy plane being z equals 0, or the xz plane being y equals 0, so on and so forth. So if you take the things, all of the points, so all of the r values here, so whatever this point is, that's centered around r naught. So kind of think of it emanating out of this r sub 0 here, this r naught. And if you take the dot product with n, remember giving 0 here is the condition that it's perpendicular. When the dot product is 0, that means you're perpendicular. So this is just saying that these two vectors are perpendicular to one another. And so if you were to go ahead and expand this all out, you get a very nice formula for this. So again, we need a normal vector and you need a point to go through. So the normal vector is a, b, c. the point that you're going through is x naught, y naught, z naught. And so you get this equation right here. So you can see the a, b, c's are the coefficients, and then you kind of center it around x naught, y naught, z naught. So you have x minus x naught, y minus y naught, z minus z naught. And so, of course, you can generate equations of planes. So this is a quick example with that. Given a point and a normal vector, you can come up with an equation of a plane very quickly. And of course, you could do things with it. You could ask when does it intersect, the x-axis and all that sort of stuff. Of course, right, this just here says that if you wanted to, this right here is just going to be some constant. This a x naught plus b y naught plus z z naught. Multiply that by a negative, right? That's just some constant. So if you'd like to, you could write your equation for a plane a little bit simpler, but you kind of lose some information. I don't really like this one so much, but sure, that's true. And then again, you can ask all sorts of things. You can ask, right, are two planes parallel to one another? Or when does a line intersect a plane? Or how do two planes intersect, right? If they're not parallel, then maybe they intersect. How do they intersect? And it turns out it looks like this is maybe like a line or something. Or this right here is trying to say, right, what angle do they intersect at? So we can define maybe an angle between planes and all that sort of stuff. And so, yeah, there's a lot that can be done with lines and planes. And so you'll see that this kind of, breaks open the floodgates to some extent, and you get a lot of types of questions. So that's some stuff that I think that you're likely to encounter in maybe day one. In day two, you'll probably, whatever you don't get to, again, I covered quite a bit here, but there's bound to be some questions that you don't get to in your lesson, and that's going to be day two. And then you also get some stuff about distances. And so here he kind of goes in a little bit and a bit here as well about distances between a point and a plane. And when we say distances, we mean the shortest distance. So what is the shortest distance between this point and this plane? Because of course, if you draw lots of lines to the plane, they probably have different distances. So when we say what's the distance, really we mean what's the shortest distance. And so you get a lot of distance equations, and that's almost certainly going to be in day two. All right, so yeah, that's a little bit about 12.5, some things you should be expecting. I would take a look at maybe the first 2 or 3 web work problems, see if there's anything that you can do. And certainly, look at those and think about them, as you're sitting through the lesson and everything, and trying to identify how can you make the connections from what you're learning to what you need to do in the web work homework. So that's my suggestion for you guys if you have a little bit of time before class. All right, thank you so much for watching, everyone. And yeah, thanks for a rather smooth quiz 1 and everything. Good luck tomorrow and have a nice weekend. I'll see you guys next week.